Welcome back again to another episode of AWS SimuLearn Solutions Architect Path. Let's jump right into it. Let's try scripted mode first. Done. Let's do it again using open dialog mode. Done. Let's proceed to build on AWS. Solution request. Review and change VPC network configurations to fix a connection issue. Step 1. This solution uses a common network architectural configuration that allows only internet traffic to reach publicly exposed AWS resources. Step 2. The web server and DB database server are deployed within a virtual private cloud, VPC, which is a logically isolated virtual network. Step 3. The web server is deployed inside a publicly exposed subnet and is assigned a public IP address to make it accessible from the internet. Step 4. The security group for the web server is configured to allow access through port 80, the default port for HTTP connections. Step 5. A route table is configured within the VPC that allows internet traffic through an internet gateway to the public subnet only. Step 6. The DB server is protected and is only accessible from the subnet in which the web server resides. Step 7. The DB server resides in a private subnet, which does not have a route table that allows access from the internet. Alright, let's now go to practice section. Practice lab goals. Explore the components that comprise a virtual private cloud, VPC. Configure a route table attached to a subnet within a VPC. Configure an internet gateway inside a VPC. Configure inbound rules within a security group to control access. Let's follow the steps here to learn how to use it. Feel free to pause the video from time to time to learn what are the options that we are choosing as we progress in our solution. Before anything else, let's check our architecture and familiarize ourselves. We can see here that our virtual private cloud hosts our underlying resources. We have both the public subnet and the private subnet that both host their respective servers. For our public subnet, it hosts our web server since this is the public-facing subnet where our customers connect. Then in our private subnet, it hosts our database server, which is our backend. This backend is supposed to be not accessible to the public. That's why it is deployed in our private subnet and only the web server have access to it. Both the web server and the database server has its own security group which determine who have access to their respective servers. The web server security group should allow access of the outside internet to its server, whereas the database security group should indicate that only the web server security group has access to it, and no other connections. Alright, let's check the settings of our subnet and our security groups. Let's go first to our web server and check our public IP address in another tab. As we can see here, we are instructed to delete our NAT gateway. Why? Because this is only used for servers in a private subnet to connect to the internet via outbound, not inbound. Since the subnet of our web server is public, we need Internet Gateway, not NAT gateway. Congratulations! We've completed the practice session. We can now connect to our web server deployed in our public subnet. Let's now go to the DIY section to complete the solution. DIY goals. Change the security group rules to allow traffic over port 3306 into the DB server. Alright, so let's go to the security group of our DB server and check the inbound rules if we can see the allowed connection of our web server security group in port 3306. As we can see here in our inbound rules, no connection is found, meaning our web server cannot really connect to our database server. Let's add. As we can see here in type section, we selected MySQL/Aurora and the port range automatically changes to 3306. This is we want to achieve that as stated in the diagram. Here in source, we selected the web server security group. This is to ensure that only the instances associated in our web server security group can only access our database. Next, let's refresh our web page to see if our database connection changes to check. Great, it is now checked. A while ago, this symbol says disconnected. Done. Let's validate our solution. Let's now paste here our database server security group name. Congratulations! We successfully attached an internet gateway to our public subnet, and we've successfully modified both the security groups of our public subnet and our private subnet. Feel free to review the solution and deep dive to the purposes of the components we've discussed here so that you can have a strong and solid foundation in AWS networking concepts. If you like this kind of content, make sure to hit that subscribe button and ring that notification bell. Until next time, folks, bye!